is on parallel lines and triangles. So a triangle is a polygon with 3 sides, and there are different types of triangles. Do you guys all know these names? So an equilateral triangle, what is that? All sides are equal, exactly. So lateral means side, equa means equal. So we have 1, 2, 3. So we have all sides congruent. An isosceles triangle. Anybody know that one? Yeah, it means that you have 2 of the sides are congruent. So 2 sides congruent. And I'm going to be really picky about this, and I'm going to say at least 2 sides congruent. Because I could actually have all 3 sides congruent, and that is also an isosceles triangle.
Wait, really? Wait, what?
An equilateral triangle is by definition also an isosceles triangle. Now, is an isosceles triangle always an equilateral triangle? No, this takes us back to our chapter 2, like our converse type things, right?
Yeah.
So the converse is not true for that. Yes, you didn't get that? I don't know if I have another one. You didn't get what? So I just passed out another packet. Yeah, did you get it? You didn't get it? All right, so how about a scalene triangle? What do we think that is?
No sides are equal.
Yeah, no sides are equal. So no sides congruent. Here, hold up and grab it. All right, so then we have an acute triangle. So an acute triangle, every single angle is acute. My line got a little crazy there. So all 3 of these angles are acute. Oops, angles, jeez. And then an equilateral triangle, or equiangular triangle, what do you think that is? Equiangular, equal angles, right? So if all 3 of those angles are the same, how many degrees is in each of those angles? Joseph, do you know? 60, yeah. So they're all 60 degrees. So did you know that an equiangular triangle is also, by definition, an equilateral triangle? Okay, the reason this is true is there's something called the base angles theorem for an isosceles triangle. And I think I've shown you this before. Like, imagine I drew this isosceles triangle here on patty paper, and I folded it so that these 2 sides matched up. So I folded directly in the middle. What would happen is that the 2 triangles that were created by that fold line are going to be directly on top of each other. Do you see that these 2 angles will be the same? Like the 2 base angles. So we always say the base angles of an isosceles triangle are congruent. So if you look at this equilateral triangle and you kind of do the same thing, that means these 2 angles are congruent. But I could have cut it this way as well, right? So these 2 angles are congruent, right? Does it make sense? So you can get all of the angles are congruent. So that's not super important, but we'll go back to that base angles theorem later in the semester. All right, so a right triangle has all right angles? Is that what we say? No, it can only have 1 right angle, right? So there's 1 right angle. So this last one was all angles congruent. And then the obtuse triangle is going to be at least, well, not at least one obtuse angle. All right, so it says, note, an equiangular triangle is also equilateral. And the same is true, an equilateral triangle is also equiangular. So if you have all the sides congruent, that means all the angles are congruent as well. All right, so we're going to classify those following triangles. So we always have at least 2 classifications. So one of those classifications has to deal with the angles, and one has to deal with the sides. Okay, sometimes we can have more than that, as you'll see in one of these. Okay, so in this first one, let's talk about the sides first. Do I have no sides congruent, 2 sides congruent, 3 sides congruent? I have 2. How do I know for sure that that third one's not congruent? It's not marked, but it's also like the hypotenuse, right? Wouldn't that be the longest one anyway? Yeah. And if there's no markings, we don't assume that they're congruent. So this is going to be an isosceles. Do you guys all know how to spell isosceles? I always joke that I should do a mathematical spelling bee. This would be a good one for the mathematical spelling bee. right, so isosceles triangle, and then what type of angle does it have? A right, so we're going to say isosceles right triangle. All right, so the next one, it's going to be obtuse. I heard that one. And we don't really know. I'm going to guess scalene since there's no markings that say it's the same, right? All right, this next one, I have 55 and I have 48. So let's figure out what that last angle is just to make sure. So if I take 55 plus 48 and I subtract from 180, I end up getting 77. Yeah, so it's scalene and it's acute. Okay, so I should have done one more. What if I have one that looks like this? It would be equilateral, which means it's also equiangular, right? It's acute because they would all be 60. It would also be isosceles. Good. Why is it isosceles? What was our definition? Yeah, because we said at least two sides are congruent. Exactly. All right, so right triangles, it says the sides that form the right angle of a right triangle are called the legs. So see how these sides come together and they create the right angle. So these are called the legs. And then the side that's across from the hypotenuse, so if I go across the triangle from it, or across from the right angle, that's the hypotenuse. Another good mathematical spelling bee word. All right, isosceles triangles. So it says the two congruent sides of an isosceles triangle are called the legs. So like this one and this one would be the legs. And then the side that's not congruent to it is called the base. Now I drew this like this on purpose. I wanted you to see that the base isn't always on the bottom. A lot of people assume that. They're like, oh, it's the bottom one is the base. So for an isosceles triangle, it's the one that's not congruent to the other two. Or it could be if it was equilateral. All right, and then as I told you, those base angles, so the angles right here and here, those are going to be congruent to each other. So it says measure the angles in the following triangles and find the sum. What is your hypothesis? So I'm going to get out some protractors and we're going to try this. Okay, you might think it's silly that I'm having you guys measure, but when I taught at IU, you would be shocked. There are lots of people that don't know how to measure angles. So we're going to do it. So we can see that those angles should add up to be 180. Okay, so we had a little bit of human error on that first one, but it was pretty darn close. 181, that's pretty close. So they should add up to be 180. All right, so it says measure angles A and B and angle 1 in the following triangles. What's your hypothesis? So this is a little bit different. So as we measure angle A and angle B, so how about this side of the room you guys measure A, that side of the room you measure B. See what we get? So you got what, B was 70 or A was 70? I got B is, I don't know, what did you guys get, like 42? 40? 42?
I guess 70 for A.
70 for A and 42 for B. So if you measure angle 1, so angle 1 is this angle that's on the outside, right? We call this an exterior angle. If we measure it, I got 112. Okay. And for the next one, angle 1, it looks like is 90. And then A was, I don't know, kind of hard to see, 60. And B was 30. So can you make a hypothesis? What do you guys think? So what's the relationship between A and B and angle 1?
They add up to be angle 1.
They do. Okay, so then that should always happen. So the measure of angle A added to the measure of angle B equals that exterior angle, the measure of angle 1. Okay, so let's think about why this has to be true. So don't write this down, but I'm going to kind of draw some things out. Maybe I'll do a blank page. Okay. So we know that if I had like 50 degrees here, 30, what do I want to do, 60 degrees here, what do those add up to be? 110. What is left for this angle right here? 70. Can you guys all get that? It has to be 70, right? If this is 70 by a linear pair, what does the outside angle have to be? 110 by the linear pair. Does that make sense? So do you guys see why that outside angle, the exterior angle, has to equal the sum of these two things? Yeah, because that exterior angle is a linear pair with the missing angle, right? And that missing angle adds up to be 180 with the other two, okay? So they should always be the same thing. That's called the exterior angle theorem. So we have two theorems that we're learning. So the first one is called the Triangle Sum Theorem. And that says if we have a triangle with angles A, B, and C, the measure of angle A added to the measure of angle B added to the measure of angle C equals 180. And the exterior angle theorem says if we have an angle on the outside, so we call it angle 1. So notice that's not 1 degrees, right? Angle 1. And I have two angles that are across the triangle from it. So it's never that angle that's right next to it, right? It's never the one that's right next to 1. It's always like across the triangle from it. Those two added together, so measure of angle A added to measure of angle B has to equal the measure of angle 1. Okay, so let's try this. So very easy questions. This is how your homework starts out. Don't you like these questions?
Yeah.
Aren't you like, woo, this is easy. So we're going to say like 52.2 added to 44.7 plus whatever the measure of angle 1 is has to equal 180. Perfect. So we add those together. So we're like, okay, what's 52.2 added to 44.7? So that's 96.9 plus measure of angle 1 equals 180.
So you subtract 96.
Exactly. So we subtract that over. We get measure of angle 1 equals 83.1 degrees. That's our answer. Okay, that's called the Triangle Sum Theorem. They have to add up to be 180 degrees. Now this next one is the Exterior Angle Theorem. Could I get this in other ways? Like I could find this missing thing, right? And then I could do 180 minus it to get measure of angle 1. But that's more work than I want to do. And it's not always going to work because sometimes we're going to have x's out there. So we're going to say measure of angle 1 is equal to the sum of the two interior angles that weren't next to it. So we're going to say 60 plus 63. So the measure of angle 1 equals 123. Quick and easy, right? All right, so as I said, sometimes we're not always going to have nice numbers. This one has x's. And that's why we really do need to know the exterior angle theorem, because this would be really gross if I had to do 180 minus 2x squared minus 44 to find that third angle. And then I had to say, okay, this angle, right, added to the other two angles equals 180. That seems really time consuming. Okay, so we don't have to do it that way. We don't have to find that missing angle. We can just say, oh, the angle on the outside equals the sum of the two angles on the inside, right? Yeah?
Would you do like 4x plus 3x plus 5 equals 2x squared?
Yep, exactly. So 4x plus 3x plus 5 equals 2x squared minus 44. I made this problem. Don't you like when I make problems? They're always so much harder than what would be in the textbook.
Are we going to factor?
We are going to factor. We're going to get everything on one side. So when I combine these, I get 7. So I'm subtracting the 7x over. I had minus 44, and then I'm subtracting the 5 over as well. So I'm going to have minus 49 equals 0. Yeah, and I start factoring. So I definitely need 2x and x. And then 49 and 1 seems a bit big. So how about 7 and 7? Let's try it. My outer swoop is 14, my inner swoop is 7. Can those combine to be negative 7?
Yes.
Yeah, negative there, positive here. So I have two possibilities for x. So I could have 2x plus 7 equals 0, or I could have x minus 7 equals 0. So I end up getting x equals negative 7 over 2, which if you guys want to see that as negative 3.5, that's fine. and then x equals 7 is the other one.
You can have negative angles.
Yeah, you can have negative angles. Now, could you have negative answers? Sometimes. Sometimes you can have a negative, but if you go back in and you plug in, like Cam's saying, if you plug that negative 3.5 into maybe the top one, see that 4x? If I did 4 times negative 3.5, that's bad. That's a negative angle, right? So that one's out. It definitely can't work. So we just cross it out. What about 7? Does that work?
Yes.
Yeah, and you can check. You would end up getting 28 degrees. The next one is what? 21 plus 5, so 26 degrees. And this last one is 2 times 49 minus 44, so we end up getting 54. And does that work? Does 28 plus 26 make 54? Yeah, so it works. All right, so it says find the value or values of the variable. All right, so I have something marked here. I did these 2 little marks right there, which means we have an isosceles triangle. So I haven't actually given you, like in your notes, the base angles theorem, but we're going to use the base angles theorem. So that means that this angle and this angle are the same. So this one has to be 75 degrees.
Yeah.
So does that help us a little bit?
Yeah.
Yeah. So what's an equation we could set up, Colin?
75 plus 75 plus x equals 180.
Yep, that's the first one. So we get 150 plus x equals 180. So we get x equals 30. Perfect. Okay, so what's another equation? Oh, Colin, you already did one. Let's see if someone else. Ian, how about you? Ian always knows. He just never is going to speak up. So how about right here with the y? What's an equation I can set up with y?
8y plus 9 equals...
How about plus 75 equals what?
180.
Colin's so excited. Yes, it does equal 180 because it's a linear pair, right? Do you guys all see that? They're right next to each other. Whoops. Plus 75 equals 180. So we start subtracting over. I subtract that 75 over. I get 105. 105 minus 9 is 96. So I get 8y equals 96. So I get y equals 12. Okay, that kind of helps us because we know that that red part that I circled is 105 degrees, right? It has to add with the 75 to be 180. So how do we get the z? Colin, what do you got?
Alright, if you add together, if you add 12, so if you did 12 plus 50 plus 10z minus 15 equals 180.
12 times, what are you saying?
So if you do 12 plus 50 plus 10z minus 15 equals 180.
Yeah, I think you're there, but I think you're saying plug in 12 for the 8y. And so that gives you the 105 degrees. So we would have 105 degrees plus the 50 degrees plus the 10z minus 15. That's all equal to the 180. Do you see it? It's the 3 angles in this triangle.
Yeah.
So you're going to add them together. So we already knew that that one was 105. So what he's saying is you can plug the 12 back in, and you can say 8 times 12 plus 9. That gives you the 105. All right, so we can continue to solve. So we're like, okay, we got 10z. I had 105 plus 50 was 155. I subtract out 15. I got 140 equals 180. So 10z equals 40 when I subtract over. So z equals 4. So we've gotten our 3 variables. Tricky, huh? All right, so the next one. I don't think it's fine. Just turn your phone off. It's fine. All right, so the next one. So we have some markings on this one. So we've got to look at our geometry markings. Okay, what markings am I going to use? Do you see it? The top and the bottom are parallel, right? Do you guys see it? Because we have these little arrows there. So we have parallel lines. Yeah.
For z, would it be negative 4? Or
I think it's positive because you'd subtract the 140 over and you'd still have positive 40.
Oh, never mind. Yeah, I see what I messed up.
Okay, and then we can draw in any of the transversals. It doesn't matter what we draw in. So I'm going to draw in this slanty line here. And I know this angle up here is x. So up at the top is x. Remember the shape that I told you to always look for alternate interior angles?
Z.
Yeah, we're looking for that Z shape. So we have our Z shape right here. So that means that this one is also X down on the bottom. So we have X in the top right and we have X in the bottom left. So sometimes just moving those angles around, finding what's congruent really helps us. So Rhett, do you see what we're going to do? What equation are we going to have? See it? Yeah, so we would do, look at this triangle in particular. What equation do we have? X plus 2x plus 90 equals 180. Do you see that?
Oh, yeah.
Yeah, you got it. Okay. So we get 3x plus 90 equals 180. So I get 3x equals 90. So x is 30. And that's it. And you can check. You guys see how you would have 30 and 60 and 90 make 180. That's a special right triangle, we call that, the 30, 60, 90 triangle. We're going to deal with those later in the year. All right, so again, I now have parallel lines drawn again. Kushal did the pencil drop, mic drop on that question. Entertaining. All right, so we're going to draw those parallel lines in so we can really see them. And that's going to help us, because if I draw on one of these transversals, this angle here is the same as this angle here. You guys see where I'm drawing? Like these little angles here are corresponding angles. So that means we can put a little A right there, super tiny. So if I zoom in on that triangle, I have everything I need. I have A here. Well, I would also have A there because they were marked with the same markings. And then I have 40. Can anybody do right away without writing the equation what A has to be? 70, good. So what is our equation? Our equation is 40 plus A equals 180, right? So 2A equals, we subtract the 40 over, 140, so A is 70. So some people are very visual, like they can just see that and be like, oh, the A's have to be 70, because 70 plus 70 makes 140 plus another 40. So if you can do that, that's fine. All right, and the last one, a little tricky. Look at how many variables. We have A, B, C, D, and E.
Also, wait, no, never mind.
Yeah, F is that angle, right? Can we do it?
Sure.
I don't know. Let's see. So we have, I don't know, what do we know already?
Oh, okay.
Yeah? What's
So,
one you know?
This is a right angle right here, and part of it says 31. So
Ah,
the other
good.
side would be 59.
Yeah, do you guys agree? 59?
So 67.
So this B has to be 59. Let me just write out all my variables. A, B, C, D, and E, right? So I have B right away. B is 59. So he's saying because they make 90. All right, what's the next one we're going to find?
I got it.
Colin really wants to go. And Beatha, how about you? Yeah, we have 59 plus 67 plus A has to equal 180. So we can add those together. So 59 plus 67, 126. We subtract from 180. So I got 54. Did you guys get 54? So A is 54, so we're good there. And we draw it in because we're like, oh, we might need that. It's a little sloppy, but 54 was there. Okay, we're going to look for other triangles. Colin, what do you think? What's the next one?
So for C, you could do 67 plus C equals 180.
Yeah, you could say 67 and C add to be 180. So 180 minus 67 is going to be 113. So C is 113. And A I can find, or D I can find in two different ways. Okay. Max, do you see the two different ways? Yeah, you can add 31 and 113 and subtract from 180. So if I do that, 113 plus 31, 180 minus it, I do get 36. So we have that one. D is 36. But there should be another way that I can do that. So look at the big triangle. Do you see how we have the 90 degrees and we have 54? 54 and you have 36.
Oh.
You could also do it that way. So
Yeah.
sometimes you kind of like zoom in on things, and maybe you don't see it, but if you look at the big picture, look at all of it, right? You can say, oh, there's a big triangle there that had 90 degrees, 54, and then that would have to be 36. So there's other ways to get these angles. All right, Colin, what do you think of the last one?
Is it 90?
It is 90.
That's a right angle to the
Yeah, exactly. I love questions like that where you have to
Yeah.
use like other ones to find the others. Ugh, those are great bonus questions. Sometimes I ask like A through M. You just never know. Could be so fun. All right, so we're going to stop there.
Oh, we're finishing our course today?
Yes, we are.